Hey everyone, welcome back to my channel. Today's video will be focusing on converting decimals to fractions, and we'll be looking at terminating decimals and recurring decimals, and we'll be converting those decimals to fractions. If you're new to this channel, please subscribe below, and if you've been here before, then welcome back. There are three different types of decimals. So the first type of decimal that we have is terminating decimals. And these are usually decimals that they end. So for example, if we have 0.78, this would be considered as a terminating decimal because it comes to an end. Secondly, we have recurring decimal. And recurring decimal means that a number or a set of numbers are usually repeated. So for example, if we have 0.787878 and it goes on and on, those are recurring decimal. And finally, we have something I like to call infinity, and these are just decimal places that usually go on and on forever and ever, and it does not end, hence the term infinity. So it goes on to infinity. So for example, 0.777777, and it goes on and on and on and never ending. So those are the three types of decimals that you need to be aware of when we're dealing with decimal type questions. We will now be looking at how to convert decimals to fractions, and in particular we'll be looking at how to convert terminating decimals and recurring decimals to fractions. Recurring decimals, we'll be looking at quite a few examples because the variations of the amount of numbers that will be recurring can change and can vary. So we'll have a look at that. In terms of the third decimal type that we spoke about, which was infinity, we cannot convert that to fraction because obviously it goes to infinity, so that cannot be converted to fraction. So that's why we're going to only be looking at terminating decimals and recurring decimals to fractions. The first example that we'll be looking at is 0.2. When converting a decimal to a fraction, the first thing that we need to look at is how many decimal places our number has. So looking at 0.2, we know that there is only one decimal place. Therefore, we're going to be multiplying by 10, and we're going to also be dividing that number by 10. So we're going to have 0.2 multiplied by 10 would give us 2, and then we're going to be dividing by 10. And from this point, all we need to do is simplify. And simplifying, we'll have 2 into 2 is 1, and then 2 into 10 goes 5 times, so our fraction would be 1/5, and that cannot be simplified any further, hence our answer is 1/5. Moving on to a second example, if we had 0.68 and we needed to convert this to a fraction. Once again, the first thing that we need to do is look at our number and see how many decimal places we have. And looking at this, we have 2 decimal places. And if it's 2 decimal places, we need to multiply by 100, 2 zeros. So multiplying this by 100. And we're also going to be dividing it by 100 to make it a fraction. So 0.68 multiplied by 100 would give us 68. And then dividing that by 100. So this is our fraction. And now obviously we can simplify this. And the easiest way to simplify this is to first divide it by 2, since both of the numbers 68 and 100 are even numbers. So dividing 68 by 2, first we'll have 2 into 6, which gives us 3, and then 2 into 8 gives us 4. And then 2 into 10 gives us 5, and then 2 into 0, which is 0. So our new fraction is 34. divided by 50. And we can once again simplify this by 2. So we have 2 into 3 is 1 with 1 remainder, so that's 14. And 2 into 4 gives us 7. Dividing our 50, we have 2 into 5 gives us 2, 1 remainder, which makes it 10. 2 into 10 gives us 5. So our new fraction is 17 over 25. And this cannot be simplified any further. So our final answer, our simplified answer is 17 over 25. We're now moving on to the more complicated conversion of decimals to fractions, and this is when we're dealing with recurring decimal. So recurring decimals, for example, if we have 0.78787878 going on and on, this can be simply written as 0.78, and then we have a dot over the 7 and a dot over the 8, and the dots represent that those are the numbers that are going to be recurring. If you were to put a fraction or a number in the calculator that recurs, you would see that there's a dot over the number that recurs or the numbers that recur. So working through an example. Before we go through an example, this is a rule of thumb to note by. So if we're going to be multiplying by, if we have one number recurring, then we're going to multiply by 10. If we have two numbers recurring, then we're going to multiply by 100. If we have three numbers recurring, then we're going to multiply by 1,000. And as you can see, the amount of numbers that we have recurring, that's the amount of zeros that we're going to be multiplying by. So if we have one number recurring, we're going to be multiplying by 10, which has only one zero behind it. If we have two numbers recurring, then we're going to multiply by 100, which has two zeros behind it. So you can see that trend. Okay, let's work through an example now. Let's erase that. Okay, so if we have, let's say we have 0.21 recurring, and we need to convert this to a fraction. So let's write out our recurring decimal. So that would be 0.2121221, and that goes on for a bit. So the first thing that we're going to do is we're going to have x equal to our recurring decimal. So we have, and we're going to label this equation 1. Let's write that in green. So we have equation 1 is equal to x is equal to 0.212121. After we've labeled our equation 1, and that is equivalent to x is equal to 0.212121, we're gonna look at our equation, our decimal, and we know that it has two recurring numbers. So from our rule, we need to multiply that by 100. So we need to multiply our equation 1 by 100. Good. So when we multiply our equation 1 by 100, we're gonna have equation 2. So let's label that equation 2, and that's going to be, let's write it in green, yellow. So when we multiply our equation 1 by 100, our equation 2 would be 100x, because we multiplied the x by 100, so that's 100x is equal to 21.2121. Yeah, so that is where we are currently. Now we have equation 1 and we have equation 2. What's the next step? What we're going to do now is subtract equation 1 from equation 2. So let's write that down. We're going to subtract equation we have equation 2, and we're going to take away equation 1 from that. And let's work through that. So we're going to have, let's write that at the bottom. Good. So we have equation 2, which is 100x is equal to 21.2121. And then we're going to subtract equation 1, which is x is equal to 0.212121. And remember, both of these equations carry on because it's a recurring decimal. Subtracting this now, we're going to have x from 100x, which leaves us with 99x. And then we have 0.212121 being subtracted from 21.21, and that would leave us with 21. So this is our new equation that we need to find for x. So we have, let's find somewhere to write this. Okay, so we have 99x is equal to 21. If we need to find the value of x, then we're going to have x is equal to, remember our 99 is being multiplied by our x, so if we need to make x the subject of the formula, then we need to move the 99, and that means we'll have to do the opposite of what it's doing with the x. So it's multiplying, therefore it will need to be divided on the opposite side of our equation. So we'll have x is equal to 21 divided by 99, and that is our fraction, and that can be simplified. So this can be simplified by 3. So 21 divided by 3 would give us 7. 7 times 3 is 21. And then 3 into 99, we know 3 into 9 is 3. And then that's another 3 again, which gives us 7 over 33. And that is how we find our answer for our recurring decimal. So 0.21 recurring is the same as 7 over 33. We're now going to move on to our second example. So if we have 0.374 and our 7 and our 4 were recurring. From our rule, we know that if we have two numbers recurring, then we need to multiply by 100. So we need to multiply 0.374 recurring by 100. Let's write that in white. There we go. So first thing we need to do is we're going to write our first equation, which is equation 1 would be x is equal to 0.37474, and this continues. And then because we're multiplying by 100, that will make our equation number 2. So equation 2 would be 100x is equal to 37.47474. So now we need to, we're following the same principle as what we did in the previous example, which is we need to subtract equation 1 from equation 2. So rewriting our second equation, we have 100x. Let's write this in white. So we have 100x is equal to 37.47474 minus equation 1, which is x is equal to 0.3747474. And when you're writing out your recurring decimals, you can write it to whatever amount of decimal points you think is reasonable to do your calculations. So you can write, if it's recurring decimal, you can write up to 4 decimal points, or 345, a reasonable amount. It's up to your discretion. So subtracting our 100x minus x, we have 99x remaining. And then subtracting 37.47474 from 0.374747, we'll have our answer as 37.1. So now obviously we need to find our value for x. So let's make x the subject of the formula. We have 99x is equal to 37.1, and obviously 37.1 is a decimal, so at some point we'll need to convert that to a whole number. So first let's find x. So we have x is equal to 37.1 divided by 99, and we cannot deal with decimal points as a fraction, so therefore we need to multiply that out. So we're going to multiply that by 10, so the numerator by 10, and once we multiply our numerator by 10, we need to multiply our denominator by 10 as well. So we have x is equal to, let's make a note of that. So we need to multiply numerator by 10 and denominator by 10. Rewriting, we have x is equal to 371 divided by 990. So that is our fraction. So 0.374 with the 7 and 4 recurring would be equal to a fraction of 371 over 990. And I think that's the lowest possible outcome, or that's the lowest that it can be simplified. So our answer is 371 over 990, and that is our fraction. We're going to work one more example, and then that will be it for recurring decimals. In this final example, I'll be going through a decimal point that has 3 numbers recurring. So I'll show you how to annotate that and also how to calculate it, which is pretty much the same steps that we did for the previous 2. But I'm just going to work through that just to give you an idea of the range of different forms that recurring decimals can come in. So our recurring decimal would be 0.241. And I want all 3 of the numbers to recur. So our dots are going to be over the first recurring number and the last recurring number. So that would be over the 2 and over the 1. And rewriting this, or writing this out, we'll have 0.241241241, and that keeps going on. So firstly, we're looking at our decimals, and we know that there is going to be 3 numbers recurring, 3 decimal points recurring, so we have to multiply by 1,000. That's according to our rule. So formulating equation 1, we have x is equal to 0.241241241, and that keeps continuing. And then our equation 2 will be 1000x. Remember, everything is being multiplied by 1000, so we have 1000x is equal to 241.241241. And as usual, we subtract equation 1 from equation 2. So we're going to have, let's use white. So we're going to have 1000x is equal to 241.241241, and then that is subtracted from equation number 1, which is x is equal to 0.241241241. Simplifying this, if we subtract 1x from 1000x, we'll have 999x. And then subtracting 241.241241 from 0.241241241, we will have 241. And then we need to make x the subject of the formula for this. So rewriting that, we have 999x is equal to 241. If we need to make x the subject of the formula, once again we divide the 999, so we have 241 divided by 999, which is our fraction. So our recurring decimal 0.241, with all three of our numbers recurring, converting that to a fraction, we'll have 241 divided by 999. And that wraps up all you need to know about converting decimals to fractions. So we've looked at terminating decimals to fractions and recurring decimals to fractions. And that is pretty much all we're going to be covering for today. Sorry that this video is a bit lengthy, but I wanted to give you a wide range of ideas of the different types or different forms of decimals to fraction questions that might arise in an exam. Thank you so much for tuning in this week, and if you haven't done so before, please subscribe to this channel and also hit the like button below. Thank you so much and see you next time. Bye bye.